What's good, math family? In this video, we're going to show you how to graph linear equations using tables. And at the end of this video, we're going to also show you how to determine if a point is a solution to an equation and if it falls on the line. In the first example, they give us the equation where y is already isolated. And they also give us the x values to plug in. So with this type of problem, we just come in and substitute. So for our first one, we have 3 times 4 minus 7. So 12 minus 7 gives us 5 for y. The ordered pair that we would plot is 4, 5. So my first point is going to be right here. Then we go back and repeat the process when x is 1. So once we do that, we have 3 minus 7, which gives us a negative 4. The next point on my graph is going to be 1, negative 4. Which will be right here. And then the last one is when x is 0. And if I could tell you, family, you always want to use when x is 0 because typically with linear equations, they will ask you for the y-intercept. And to get the y-intercept, we just have to make x 0. So I always suggest that you use that point. All right. So y is negative 7. We know the point is 0, negative 7. And that last point will be right here. So when we go through now and we draw a line through these 3 points, the equation for this line is going to look something like this. And as a rule of thumb, we really only need 2 points. But I always suggest 3 because if you make a mistake, it's easier to catch it when you have 3 points because they won't all line up. Now, if you want to determine if this is correct, you can use the slope, right? The rise over run, which will be 3 over 1, to determine if these is correct. So when I go from this bottom point up 1, 2, 3 over 1, I know that that's correct. And if I continue with that rise over run, I will end up at the very first point that we plotted. In the second example, they give us the equation in standard form, meaning the x and y are on the same side of the equation. And the reason why I'm going to tell you to convert it and isolate y is because let's look at it like this. So let's say we picked 0, we picked 4, and we picked 8 for our x's. So let's say we substitute in 8. So when we substitute 8 in, we have negative 3 times 8 minus 6y is equal to 0. So we get negative 24 minus 6y is equal to 0. Now, when we add 24 on both sides, we have negative 6y is equal to positive 24. Then when we divide, we get y is equal to negative 4. So we know the ordered pair would be 8, negative 4. So when we go ahead and plot that point, it's going to be right here on our graph. Now, the best way to go about this, let's erase, is this. Let's come in and convert this equation and isolate the y. So we have negative 6y is equal to positive 3x. We just added. Now when I divide by negative 6 to get that y by itself, we have y is equal to negative 3 over 6, which will reduce to negative 1/2 x. So this is the equation or the line that we're basically graphing. And if you look at it like this is less steps for us to solve. So please always isolate the y. It's optional, but it's the best choice. And I'm going to show you why. So let's say we go in now and we repeated that process. So we have negative 1/2 times 8. We know half of 8, and that half is negative, is just negative 4. So less steps, less likely to get it incorrect. When we do the same thing for when x is 0, right, we know that y is going to be 0. So this graph is going to pass through the origin. So there goes that point. Then we repeat the process, right? We have negative 1/2 times 4 now, because that's what our x is equal to. This is going to give us a negative 2. So we know that point is going to be 4, negative 2. So we could plot this point right here. So now we have 3 points, family, and we could draw a line through all 3 of them. So the line for this equation is going to look something like this. And if we want to make sure that it's correct, like I said, we could use that rise over run. So we go down 1 over 2. Here goes another point. Down 1 over 2. There goes another point. So this matches up with our rise over run of 1 over 2. The next 2 examples are special cases, and we're talking about when there's only one variable. So this says x is equal to 5. So no matter what, we know the x value in our coordinate is always 5. That doesn't matter if we have a -1 for y, a 0 for y, or even a positive number like 3. What's going to happen is that our x coordinate is going to stay the same. So if I went to graph these points that you see me writing, this is what it's going to look like. We're going to have 5, 0, which is right here, 5, -1, and 5, 3. So this is going to be a vertical line. So no matter what value we have for y, the x's are always going to be 5. So this type of equation or this type of line is a vertical line and the slope is undefined. There is no slope at all. So please be mindful when you have this type of question, and we're going to go on to the next special case. In the second special case, they give us y is equal to -3. So no matter what x we use, whether that is -2, 0, or even +4, our y's are always going to be -3. So when I plot these points, right, we have -2, -3, which is right here. We have 0, -3, and which is right here. And then the last point, which is 4, -3. So with this type of line, family, what we notice is that no matter what happens, our y value is going to stay the same. It doesn't matter the x that we use, whether it's 1, 2, 10, 20, or even -20. So this is going to be a horizontal line. And with horizontal lines, we have to know that we do have a slope. Our slope is going to be 0. And you could always use the slope formula to determine this. So let's say we came in and we used the first 2 points, -2, -3, and then 0, -3. Once we plug this in, we'll have -3 minus -3 divided by 0 minus -2. So what happens is we're going to have 0 over +2, which is equal to 0. So there is a slope, it's just 0. In the last 2 problems of this video, and we really hope that you found it helpful, we're dealing with, does this point fall on the line? And this is a trick question, because if the point falls on the line, it is a solution to the equation, meaning that when we plug it in, it's going to give us a true statement. And they give us the x and the y. So what they're saying is 21 is equal to 6 times 2 plus 7. When we simplify this, 21 is equal to 12 plus 7. So we're saying 21 is equal to 19. So no, the ordered pair 221 is not a solution to the equation, and that point does not fall on the line. In our second example, when they give us y is equal to 4x plus 10 in the ordered pair 2, 10, we do the same thing. So 10 is equal to 4 times 2 plus 2. So when we simplify, we're saying 10 is equal to 8 plus 2, which is a correct statement. So yes, the ordered pair 210 is a solution to this equation, and that point does fall on the line y is equal to 4x plus 2. We really hope that this quick review on how to use tables to graph linear equations was helpful for you, math family. If it was, smash the like button for us, subscribe to the channel, and leave comments down below if you had questions on this video or if there's videos and topics you'd like to see on our channel in the future. Thank you guys so much for watching Algebra 1 with Mr. Peters.